My name is Xavier Ducrohet. I work on developer tools at Google on the Gradle Plugin and other things. So let's talk about 3.0. So a big focus of the last 12 months have been on performance. We've also done some features, like support for Java 8 language features, instant app and things like that. But I'm going to focus exclusively on what we did, in part in collaboration with the Gradle team, to improve performance in our plugin. So there's multiple aspects of performance. The first one is just making more of our task incremental. We have a bunch of tasks that take a lot of time, so we fix some of that. And then the bigger pain point was allowing builds with a lot of modules to actually be fast. A lot of people are trying to switch from one or two small modules or large modules to multiple smaller modules in order to bypass some of the incremental defect that we have, and then they run into scalability issues, so we wanted to fix that. And then caching. I'm not going to talk too much about caching. I'm sure you've all learned about it this morning during the keynote. We are working on making all of our tasks cacheable, and so that's something that we started a while back already. So let's talk about incremental tasks. So we have focused mostly on the biggest tasks. One of them is resource processing. So if you look in 3.0 Alpha 2, we enabled APT 2, which is basically a new flow. Before APT, we take all of the resources and compile them. It takes a folder and it outputs one binary, and that's it. That's not incremental at all. So APT 2 is incremental in a way that it can process each file separately and then creates a small binary file that represents that file and then merge everything at the end. So with the incremental state that we get from Gradle telling us which file have been removed, added, changed, or whatever, then we can just call APT2 on this one and just do a merge at the end. So that's one aspect of it. The other thing that we are working on is if you have a library project that has a lot of dependencies and a lot of resources, you may have noticed that if you do a dash profile, that merge release resources is taking like a lot of time for library project in particular. So we're fixing that to make that faster, to avoid doing a full merge of all the transitive dependencies. It should be coming hopefully in Alpha 5. And then we have more optimization that will come in the future, but it's an area that if it's a big hotspot for you, we know that we're working on. So we're aware of it and we're working on it. Java-C compilation is now incremental out of since 3.4, Gradle 3.4. Then you have also compilation avoidance, where you can have if you change a non-ABI change, you don't have to recompile all of your consumers. And then you can have manual compilation avoidance by using API versus implementation instead of the compile dependencies. It's part of 3.4. We support that fully in 3.0. I encourage you to read about API versus implementation on when to use which one. And as Hans said this morning, we are working on an annotation processor. We know it's basically the last big bottleneck for a lot of people that are like, yeah, incremental support for Java-C and annotation processor, and it's not working. So we're aware of it and we're working on that. Dexing, we used to dex everything at once, basically, or at least per jar, like per module or per dependency. At least for the sub-modules now, we're doing it on a per class basis, and we do a merge at the end. That was introduced in 3.0. I think we started in some version of 2.4, which was renamed 3.0, but it should be there and it should be faster. So we have shrinking. We have an experimental shrinker that is somewhat incremental, or rather is better at doing an incremental dex after it. It doesn't do obfuscation, and it's meant to replace progard. You can use progard equal false to enable it, which is a little bit counterintuitive. We're actually working on a better DSL for that right now. The issue is that in the Gradle files, in Gradle you say, or in our DSL you say basically run progard yes no, and then in the rules file you actually have actions, obfuscation, not obfuscation. So we're working on a new DSL that will make that more in the DSL, where in the DSL you say I want to obfuscate versus minify, and that will make things easier. And then we'll be able to automatically, if you're in debug mode and only use the new only use shrinking, then we can enable a faster shrinker for it. And then APK packaging, some of you have very large APKs, 10, 20, 30, 40 megs or more. And generating those actually take a lot of time. There's a lot of compression going on. So since 2.3, we have an incremental zip task that basically does that automatically. And we also, we used to do zip align after. So we used to do we create the APK sign, and then after that we zip align it, and now all of that is done incrementally in the same task, so it's a lot faster. OK, so we still want to solve, even though we are making a lot of task incremental, having a lot of modules can be very beneficial, right? First, if you have a gigantic task that reads a lot of input files, keeping state of all those files in order to make the task incremental can be complicated and error-prone in some cases, but also can be just not super efficient as basically sharding it into a lot of smaller tasks. And then there's things that, like running tests, for example. If you have a big module with 1,000 tests and you change one line of your production code, you have to run all your tests mostly, right? If you split that in 10 modules, you may only run 1/10 of your tests, which is just faster. And so having a lot of modules is beneficial anyway, and we wanted to make sure that if you want to have a lot of modules, then Gradle, or rather our plugin on top of Gradle, will scale properly. So that's been really like a big focus for 3.0. So the first aspect of it that was extremely slow, especially in 2.2, was configuration time. It was mostly due to badly optimized code. We fixed that in 2.3, but then we still had a big issue, and the biggest one was we've resolved dependencies at configuration time, which was terrible. Actually, the build scan would probably tell you, hey, you shouldn't do that. And we solved it. That was actually fairly complicated, which I'm going to talk about it in a minute. And then we did a bunch of other stuff that has some impact. For example, in order to do multi-APK or split, we used to, during configuration time, go and look at all your resources to figure out which density you're using or which ABI you're using. And now we do that dynamically during execution when needed only, which means that we have some API, especially around the variant output API, that used to be, you could run that API during configuration time because we knew what we were going to create as far as output. Now we don't anymore, so those API have been broken a little bit. But the reason we are doing it is to have configuration time as fast as possible. OK, so let's look at why resolving dependency was slow in our case, and why making that not be done at configuration is not that easy. And the big reason really is the big AR that we have, right? Adam talked about it a little bit during his keynote, where he said that creating an AR file is not that awesome if all you want is the manifest inside, and all you want really is the manifest, right? But we couldn't really deal with that before. So what we did is we resolved dependency during configuration. We looked at all your dependencies, and whenever we found an AR, we would create a new task and say, hey, unzip that AR in order to go read the content. And because we wanted to create tasks, then we can't do that really during execution, because once you're done with configuration, the task graph is locked, and you can't do anything. You can't add new tasks. We could have created a task per variant and do all the unzipping there. But then if you have two variants using the same dependency, both of them are going to try to extract it. It's kind of like, it's a little bit messy. And then after that, we need each task consuming the content to be set up at some point, and we would have, during execution of that task that basically resolve the dependencies, to also go and reconfigure the task downstream to give them their input, which goes kind of like a little bit messy. We actually tried to do that in 2.4, the one that was renamed to 3.0. But we basically scratched that to just go with like new APIs. So at the root of the problem, the AR is something that contains like 14 different artifacts. And if you compare that to a jar, like a jar is the same, right? It's a zip file that contains stuff, except that both the JVM and JavaC can just use that jar directly, right? None of the tools that we use are able to directly consume an AR and just pick whatever they need in there. There's a jar in there, so we need to extract it and give that the jar to JavaC, et cetera. So we really need to unzip it. So we needed new APIs. So the first one that's obvious is we need to be able to have a submodule publish all of the content separately from, like before you could only publish, you could publish more than one item, but there was no way to consume them separately, right? You would consume everything. So we needed a way on the publishing side to say, here's my manifest, here's my classes, here's the resources. So we needed them to consume them separately. And then importantly, we still have AR, right? Like the external dependencies are coming as AR. And so at some point, we still need to unzip them in order to consume the content. But we don't want to have to go and do unzipping them or creating tasks to unzip them, because it's just not efficient. So we worked very closely with the Gradle team in order to make sure that Gradle would have APIs that really serve our purpose. And we used a lot of nightlies, just to give a lot of feedback. And it's been a really great result, I think. So we have new APIs in 4.0 that allow us to do publishing and consuming in the way we need it. We have artifact transform API, which I will explain a little bit. And we have those new attributes that allow us to do variant dependency management. So if we look at consuming and publishing, but let's look at it from the consuming side, I want to be able to say, look, I'm a task, and I have submodules and external dependencies. Just give me all of their manifest, right? And I just want it to happen. And I want to have the proper dependency, right? So if I ask for the manifest, I want to get as a build dependency only the tasks that generate manifest, not the tasks that generate all the items from the library. So it used to be that, if you're familiar with Gradle, you have configuration object and you can do configuration.getFiles. Now, if you do that, what you get is a list of jar and AR, which is not what you want, right? So we have a new API that basically gets you an artifact view, and then you can configure it with saying, basically, I want Android-manifest. And that's a type that we define that's internal, that as a user, you don't really care. And we have one for basically all the 14 items that we have. And so what that returns is an artifact view, which has an artifact collection, which gives us access. There's some case where we need to have internally like a lot of information about the artifact, not just like this is the file, but also this is the file, it's coming from that module or that external dependency so that we can do some things. But the one that's more interesting is just the file collection. So you do artifact view.getFiles, and you get a file collection. And for those who don't know, a file collection is basically a collection of items, files, but it also includes task dependency. And so that task dependency here in that file collection is going to be the artifact that contains, external artifact that contains the manifest, and the tasks in submodule that create those manifests. And so we can use that as an input file in our task, like our merge manifest. And then it's lazy, so it's awesome. And just setting that up in our task does not actually resolve those dependencies. It just it doesn't happen. But then when Gradle tries to look at, do I need to run that? It can query it. It gets all the task dependency. It will go and download the stuff on demand, right? Like before, just for us to resolve dependency on the configuration side meant also that every single artifact that you depended on that was external was downloaded during that, which was terrible. Because if you had two variants and a variant that only one of the variants depended on something, and you build the other one, you're going to download anyway everything that every variant needs, right? So now it's really on demand only for what you need. And so then we get basically exactly the dependency that we want, and the task runs much faster. Well, the task itself doesn't run faster, but overall it will run faster. So on the other hand, on the publishing side, it's exactly the same, right? Our plugin basically publish a bunch of stuff. Every time we publish something, we associate it with a particular artifact, and and then it gets connected to the other side. Now I mentioned that we needed to support those external bundles, right? So we still have external ARs. And we don't want to create a task for them. We don't want to create one task that takes care of all of them, and we can't create a task per because that's too early, right? So that's where so that's what we would do before, right? We would, during resolution, resolve the dependency, create a task for all of them. Very slow. We don't want to do that, right? Okay. So now we have those artifact transform. So it's a new type of task, quote unquote. It's not really a task, but it's a new artifact that basically you set it up as saying, I want to transform that convert from an AR to an Android manifest, right? And then when you have a task that consumes Android manifest using the API I showed you, basically at some point Gradle will be like, oh, that's an AR, but I know how to convert it into a manifest. I'm going to go and run that transform. Now we don't actually go directly from from AR to Android manifest. Instead, we go from AR to exploded AR to unzip it. So this one actually does work. It goes and it unzips it somewhere. And then we have a bunch of transforms that go from an exploded AR to a content. And we have 14 of them, basically, right? So the thing that's interesting is that it's not a task. The output of the transform is not in your build file, right? It used to be the case that when you had two modules and they both depended on app compat, both of them would go and unzip the AR in there, and it would be in the build file. And hey, you do a clean build, and the next time you do a build, it re-unzip all of that. This one is actually in your home directory under .gradle/caches. It's basically the same location where it puts all the downloaded artifact, and so it just runs only once. It's cached, and you don't have to think about it, and it's faster. It's just much better, right? So this is a great API that allows us basically to just say, I just want an Android manifest, and it just takes care of transforming stuff, and we don't have to think about it. Okay, so in summary, for the dependency resolution, the new dependency is much better because it's lazy with an API that's very easy for us to do. Like we used to do a lot of processing in order to deal with all those dependencies. We would actually not use, I mentioned earlier, like, configuration.get files. We would not do that. We'd use a separate API that would go through like all the task graph and really try to set up. It was kind of a mess. It took a lot of time. And so now it's just done at execution. What we do during configuration is very quick and lazy, and it's much faster. And the end result, right, is that, Hans talked about all those speed up in build improvement, is that we have a task graph where, like a manifest merger task just depends on the task that generates a manifest. It used to be that we had this big bottleneck where any task on an app would consume every single artifact, of every single libraries that would go through zipping it, unzipping it. And if you look at the task graph, it was kind of terrible. And if you looked at a Chrome trace output of it, there would be a lot of time where a lot of CPUs would not do anything, right? Here you could have a CPU just end up doing merging of manifests while the other one merge resources, while the other one uses, the scheduling doesn't work that way, but we can do a lot more things in parallel, and that's where we gain a lot of the speed up in 3.0. And it scales also, right? Because before, the more module you had, it was just, the more module you have generally, the more large your dependency graph are, and therefore the more computation we had to do, and it was just kind of terrible. OK, so we also saw this morning during the keynote the worker executor stuff. So I want to talk about it a little bit and how we are going to use it. So it's the API that will allow us to run two tasks inside the same project in parallel, right? And then there's also the remote workers, which allow you to use the same API to easily just run something in a separate process that is long-lived, that basically survive, the end of the build, and when you rebuild, the process is still there, and it launches them on demand, and also depending on the load of your machine, it may launch more than another, which means that if your CI server has plenty of RAM and plenty of CPU, and you want to run, dexing in parallel, like 60 dexing in parallel, but your laptop doesn't, then you can still have the same configuration, right? Like here we have a problem where right now, because the memory, we're running stuff in process a lot because we want long-lived process. But you have to basically set up Gradle in order to deal with the worst-case scenario, which is ProGuard mostly. If you're running ProGuard, you may be like, OK, I need 8 gigs to give to my build.gradle. But then you always have 8 gig even if you're not using ProGuard, right? And then you have a larger VM, which means that at some point it's going to do some garbage collection of a lot of objects. It's going to take a lot of time, and it's going to pause all of your process, right? Another advantage of having a lot of processes is that they do their own garbage collection. So if you have 3-4 worker process and one of them do a GC, first it's going to be a faster GC because it's a smaller VM anyway, and then it's not going to pause any of the other VM. So anyway, it's going to be better there too. So there's a lot of advantages. And the way it's working is that, the way it's set up, the way they showed us this morning is that actually I'll show you here, you submit a runnable that then gets created in a way that is guaranteed not to have side effect, right? The problem is that right now, in a task, you can do so many things that it's not safe to run them in parallel because you can go from a task and touch, the field of another task, and it's kind of a mess. So here what we have is basically very simple, right? We get the executor, and we just submit one action, and then we return right away, right? If you look at worker executor, there is a wait method, but we don't call it here. If you submit stuff and then return, then Gradle will know that, hey, this task is still doing stuff because the executor is actually doing stuff, but it's safe to go and schedule another class. So there's, it's great in theory. There's still some work to be done. So don't expect the 3.0 plugin to make fully advantage of that. There's two reasons you want to use the worker executor. One of them is run stuff in parallel, and I'll sort of include the remote worker process in that category. And the other one also is to solve the problem that we currently have, which is that when we try to multi-thread a task, we need to spawn some threads, but it's a new thread pool, right? It's our thread pool. So we have a shared thread pool for our plugin, but it's not the thread pool that Gradle uses to make the parallel task run. And so you have too many threads, and we actually have people complaining to us that their machine has basically stopped being responsive because too many stuff is happening at the same time. So using the executor will also allow us to do multi-threading in a way that is a single thread pool. And so if you have a task that's running 2 things in parallel and you only have 2 worker process, then it's not going to go and schedule another task for it because it's busy doing those 2 here. So the problem is that right now we can do either make a task runnable intra-project or make a task multi-threaded because we can't just yet have, like inside this runnable action here, I can't go in and create like sub-worker actions. So we're going to do some of it for 3.0, but not everything will be properly by the time we ship 2.0. Basically, the tasks that right now are not multi-threaded we're going to try to make them use that new mechanism. The tasks that needs to be multi-threaded are not going to use that mechanism until this is fixed. And it's not going to be fixed in 3.1, so it's probably going to be, 4.1 is going to be 4.2 at the earliest. So it's going to be a little while until all of that is fixed. So it's coming, hopefully this second half of 2017 it will come, but it's not going to be in 3.0. If you start 3.0 and expect like everything's going to be completely parallelizable, it's not going to be the case just yet. But we're going to work on it. All right, I want to talk about variant-aware dependency management a little bit. It's a pretty big challenge. I think it's one of the earliest bugs that we have on our tracker that, or the bug that took the longest to close. I think it's probably 3-year-old or something like that with like a lot of stars, people complaining about it. And, hey, my app in debug mode consumed the release version of my library. And so finally, we fixed it. I'd be very excited. So the way it works is we have this new API that I mentioned earlier. We have, attributes. And so we put attributes in configuration, the producing configuration, so your library, and your consuming configuration on your app module or another library have the same attribute, and they're just being matched. And there's some API to decide what's compatible, and if there's more than one thing is compatible, how to disambiguate the situation. So if we look at a very simple case, you have an app on the left. It has a debug, and then you have a library with debug and release. They all have attributes. So there's a build type attribute. And debug, consume debug and release is not considered compatible. That's pretty basic, right? So there's another case where you have a flavor in your app, and so you have another attribute. And here there seems to be some confusion with people. It's fine, right? It's like it's not a problem if on the producing side you don't have it. It's going to be OK. In fact, it's the same in the other direction, right? If you have a flavor on the other side, technically debug is going to choose this one. Now there's a little, I kind of hit stuff here because there's actually more, there's 4 variants really on the library side, right? There's also release. But here it works, you have debug. Basically all the attributes need to match if you request them. If you don't request them, that's fine. So here's the example where it becomes a problem is, if you have, a flavor that you're not asking for, and here you have blue debug and red debug, and which one should you choose? And so it's going to fail by default, and it's going to fail with something like that, which is awesome. It has a lot of information, but I see a lot of developers being like, hey, the build is broken, fix it. And they file bug to us saying, look, it's broken. OK, so let me help you here. The first thing to look at in that particular case is it can choose between the following configuration, those two, because they all match everything, right? And I think part of the problem is if I look at the attribute of one of them, on the first 2 lines, I kind of reordered the line. It says found color blah, but wasn't required. And the but wasn't required is like, hey, it's wrong. It's like, it's actually OK, right? That's what I was saying earlier. Even though it says but required, it doesn't mean that it's a problem. It's fine. It wasn't required, and it's still compatible, right? And then after that, it found a bunch of compatible values. So basically, it found, both red and blue. OK, so you need to fix that. So how do you fix that? The way to fix that is basically on the app, say, OK, I need to pick a color, right? I can't not pick a color. I need to pick a color. And the way you do that, it's basically you want to manually go and add the attribute on the app. And we don't want you to have to go and manually set the attributes. First, all the attributes are actually typed. They're internal classes, and we don't want to do that. So there is a DSL for it. So during I/O, I showed that DSL, on the Android blog flavor selection, and we just removed it. We moved it instead to both flavor and build type. So here, if you want to apply it to everything, you can just go and put it on default config, flavor selection. Color is the dimension, and then blue is the value of the flavor. And that means that because it's variant aware now, you can actually go and do that if you want. So here, for the debug, you want to consume blue, and for the release, you want to consume red. I don't know why you would want to do that, but you can do it if you want. I guess it's more useful if you have like 2 different dimensions, right? You have an app that has some flavors, and a library that has some flavors, and they're not the same dimension name, and they're not the same value, but they kind of match one-to-one, or maybe not necessarily one-to-one, and you can just go and select stuff. Of course, so if you set up both on default config and on flavor and on build type, the same kind of priority as we have for everything will win. The build type will override the flavor, which override the default config. OK, here's another example, which like a lot of people have been in that situation, so we really want to fix it because it's not working by default. So in my app, I have a third build type that I call staging, and I don't have it in my library, right? We see that a lot, actually. And so it's just not going to work, right? Because what you're going to get is that, an even better error message. It's not clipped. It literally just finished right there. So this is all of it. And so the big part here is unable to find matching configuration, right? So none of them basically match. And so there are 4 of them. And in fact, if you look, I'm trying to resolve staging compile class paths. And so, part of the whole compilation avoidance stuff, each project output both a API and a runtime, right? And the configuration. That's the stuff that Adam was showing this morning. So one of them is, API element is for API, and then runtime element is for actually runtime. And so here it's normal that debug runtime and release runtime element are not compatible, so you can kind of like ignore them. In fact, if you look, there's a internal, attribute set up by Gradle that's like, usage. That is set, one says compile and you ask for compile, and the other one says you ask for compile, but it found runtime, and so it doesn't work. So we can kind of ignore those two. And then if we look at the other, basically it tells you, right, for build type attribute, you ask for staging and you found debug or release, so it's not compatible. OK, so how do we fix it? Well, I can't go and add a new attribute on the consumer because the attribute is already there, just with a different value, right? So instead, what we need is, similar to dependency resolution, we need a matching strategy, right? And that matching strategy is not per variant. It's really at the module level. And so what we want to do is we want you to be able to say, look, if you have staging, I'm compatible with staging or debug, right? We think that's probably the best way to express that. There is an underlying API that technically you can do a lot more complex stuff, but we probably, we want to have a higher level API that will let you do that, because if you have to go and implement all the stuff, it's going to be complicated, and we don't want you to do that. We want to offer a better way of doing it, an easier way of doing it that will solve, hopefully, most of the use case. But if you need something custom, then you could do something custom too, right? We won't prevent you from doing it. And so that's for build type, but technically we might want to do the same thing for flavors, right? So here we say orange is compatible with orange or red, and so if you had a flavor, that said basically you're trying to build staging orange and it's going to pick debug red instead, right? We could do that. So how do we do that? You can't do that. So there is, the API is there in 4.0, but it's missing, one small thing in order for us to do it. Thankfully, that API is in 4.1. 4.1 M1, the milestone one, was released like 2 days ago. So probably next week, we're going to switch 3.0 alpha to 4.1 M1, and we'll start implementing that API, that DSL. And it should probably look something like that. Don't quote me on that. It's likely to change. Basically, the attribute matching area, and inside you will say, hey, build type staging is compatible with debug. And it's going to be an order, right? So like for flavor, for dimension color, orange is, if orange is there, I'm going to pick it, right? It's priority, and then pick red. And if it's red is not there, then pick magenta or whatever, right? So it will be something like that. OK, so I want to mention, like, there's some other usage of those attributes, right? Those attributes are extremely powerful. The first thing that I mentioned, is the compilation avoidance, right? So you have API element, runtime element, and they have this usage attribute that allow basically Gradle to be like, hey, I'm trying to build something for compile. You have 2 of them. I'm going to pick compile instead of runtime, right? And then we have it also in the feature plugin. So, a feature plugin, in order to build Instant App, is a plugin that is able to both build an AR, although we don't build an AR anymore, right? We build the content separately. That's why I say AR artifacts, or a feature artifact, which is just basically a small APK. And we wanted to do that so that people building Instant App can share code between their main full monolithic application and all their little features. So what we end up doing is that plugin will create twice as many configurations that we used to do. So we already have debug and release in both compile and runtime, so that's 4 of them. And now we duplicate that between 4 AR and 4 feature, right? So we have 8 of them. And we have a new attribute basically called Android type value that allow us to do that. So it has different value. There's APK, there's AR, there's feature, and basically we have some matching strategy. So APK is for either an application or test application module. They need to be able to consume AR. AR only consume AR, and then feature can either depend on an AR, so it needs to consume it, or it depends on a feature just as a pure compile. And so that's the part that's interesting, right? It's like when a feature consumes an AR, it's going to consume both compile, the classes both for compile and runtime because it needs to package the AR inside the feature. But when it depends on a feature, the configuration that are exposed by that module are basically compile only, right? So the dependency that you do between the two is just compile, right? But that other feature does not expose its classes to the runtime. It only exposes its classes to compile so that I can basically go and depend on them and build against them. But when I package my feature, there's nothing coming from there. So basically, as a module, you can say, yeah, here's some class to compile, but there's nothing for runtime because you should not depend on them directly, because ultimately, those two features are already installed separately on the app. So we have a lot of control there, and it's really awesome. OK, I want to finish a little bit talking about our API. I mentioned earlier that we kind of broke the API for the variant output stuff because we are trying to do things more lazily now. We realized that there's a lot of issues and pain points right now with our API. The first one is kind of like more for us. We know that there's a lot of developers trying to access internal APIs in order to do stuff. So we recognize that, and we want to fix it by making public API for all the things that you guys are trying to access. But we also want like an API that makes more sense. Right now, the variant API happens after the tasks have been created. And you can either manipulate the variant API or you can manipulate the task, but the API on the task are not stable. I mean, they're not really like public in a sense that we officially say, hey, these are the APIs. So it's kind of like a bit of a mess there. And like if you change something on the variant, I can guarantee you that some property on the variant, you touch it here, it will impact the task that has already been created because it's dynamically linked to the variant, and some other property you change it, and nope, it's been copied there, and you can't actually change it. So we're starting to work on that. It's going to be a big focus once we finish the performance. Not that we are going to be finished with the performance, right? It's going to be, at some point we're going to ship 3.0, and then we'll start continuing. We'll continue to work on performance, and then we'll work on API as well. Yep. And with that, we have a bit of time for questions. Yes. When would I recommend migrating to 3.0? It depends on your, it's like it depends on whether you want to wait until it's stable or not, right? We don't know for sure, but I can tell you that it's not going to be, at the earliest, it's going to be like August or something like that. It's not going to be before August, so that gives you an idea. We don't want it to be December, right? So in late summer at the latest, I think. But we don't make any guarantee on when it's going to be available. Yes.
What about like remote execution? So you can add like the ability to like execute a task on a different machine.
Remote execution. We are not really working on that at the moment. Even if we were, I think we'd prefer like Gradle to provide a mechanism for that rather than try to hack something. I think, yeah, it's not really a focus. I think we want to make sure that it runs fast on, I think cache is going to help some of it, not necessarily everything. At this point, we want to make just the build be fast, right? And then cacheable, and then see where the bottlenecks are. And then we'll see if it's something that really is going to help a lot of developers or not, and then we'll investigate. But we haven't really talked about it at all right now. Sorry. We can talk after to see what your use case is or your environment. Yes?
You
So details about work on annotation processor, not really. We're working on a spec for it. I think we have a good plan. I think it's a matter of implementing it. I think we want to basically, I mean, we own, like data binding. So I think, we're probably going to start looking at implementing it in data binding first, then see, whether that's the way to go. And then we'll talk more publicly about the plan. And we definitely want to involve the community to both try it as a prototype and also to talk to annotation processor authors to make sure that, because there's going to be a little bit of impact on the processor itself. And so we're definitely going to reach out to people in order to make sure that people are aware of what we're going and that everyone is okay with it. But we don't really have a timeline, but we want it to be this year for sure. But it's not going to be a couple of weeks either. Right?
Yeah.
Yes.
So all the compile avoidance and all that stuff, are you guys planning to really support the Kotlin, or are you just relying on JetBrains?
So the question is about compilation avoidance for Kotlin. So there's, it's interesting. Technically, the Kotlin compiler could do the right thing, right? I mean, actually, out of the box, it should work because the way the Kotlin compiler is set up is it's going to ask for the compiled class path, right? And then it's automatically going to go and get only, well, OK, so there's two compilation avoidance, right? The first one that I want to talk about is the API versus implementation, right? So if you have a module that depends on something that has some dependency marked as implementation, whether it's the Java compiler or the Kotlin compiler, it's just not going to see those transitive dependencies, so it's going to work, right? So there's no problem there. Now, the other aspect which Gradle introduced in 3.4, where Gradle basically will go and create snapshots of the classes in order to only look at the APIs rather than implementation, so that Java-C is not run if an implementation changes happen. I think it's something that Kotlin needs, like their compiler team needs to look at. We discovered actually recently that if you start doing that, you're going to have problems because if you extract only the public, signature of like the code, but you have some function in Kotlin that are inline, then you can't inline them anymore. Right. So you can just go and randomly just strip the bytecode of all the implementation and say, hey, this is the API jar, nothing changed in it, so you don't need to recompile it because of the inline stuff. So I think the Kotlin, I know the Kotlin team is looking at it, but right now it's basically not incremental, except for when you do manual compilation avoidance, which is not quite the same, right? But it's one way to do it. Any other question? No. All right. Thank you, everyone.